Alright, let's go and get this done. You are looking for the areas of regular polygons and composite figures. So today you will find the area of regular polygons and composite figures. Woohoo! Anyways, alright, so what is a regular polygon? Okay, a regular polygon is a polygon where all the sides measure the same thing, or they are congruent. Okay, so just so that we know, we can say that any regular polygon can be inscribed in a circle. In other words, there's a circle that will connect all the vertices that will go around it, or there is a circle that can circumscribe, means it goes around it, a regular polygon. In this case, you see here I've got a regular pentagon, a five-sided figure that is inscribed around circle P. And circle P is circumscribed around that pentagon. Now, what does that give me? That gives me some stuff to know about. For example, if I go from the center to the vertex of that polygon, that would end up being the radius of the circle, and it is also going to be called the radius of the polygon, or the pentagon in this case. So if you have a line that goes to the corner to the vertex, that is still going to be called a radius, but this means something different because we're used to just thinking about radius with a circle. If you have a line that goes from the center to the side and makes a 90-degree angle, that will be called an apothem. That will become important in a minute. And then if you have, say, two vertices joined together to make an angle through the center, that is called the central angle. That's important because if you take the number of sides and divide that into 360, that will give you that angle measure. For example, but I do have some more things I want to say. So what is an apothem? An apothem is a segment from center to the side that is perpendicular. It is also the height of an isosceles triangle inside the regular polygon. And that becomes important because that allows us to create a formula that will be much easier, and I'm just going to give you that formula to help you find the area of a regular polygon. It's pretty simple. Okay, what is the central angle? The central angle has its vertex at the center and its sides pass through consecutive vertices. And again, keep in mind that if you divide the 360 by the number of sides, you would get what the central angle is. So let's look at an example where we name everything. So here's an example. You have a regular hexagon, which means it has 6 sides. And then if I wanted to say, what's the center? The center is point R. Fairly simple. What's the radius? The radius is either RK or RL. Either one of those two lines that goes from the center to a vertex. And then the apothem. The apothem is RS. It goes from the center to that point on the hexagon. That makes a 90-degree angle. The central angle would be KRL or LRK. And to find the measure of that angle, all you would have to do is take 360 and divide it by the number of sides, which is 6. And so that would be 60 degrees. So that means right here, that is 60 degrees. Okie dokie. Fairly simple, I know. Alright, so how do I find the area? Again, I've given you all that information so you just have knowledge. But here is the area. There's ways I can show you how to prove that, but I'm going to keep it simple. All it is 1/2 the apothem times the perimeter of the figure. So you got to make sure you got to find the perimeter. How can you find the figure? Add up all the sides, or multiply. Since it's a regular one, you multiply the length of one side times the number of sides. So for example, we're gonna say this is a regular pentagon because my drawing skills are supremely great. Anyways, so here's a regular pentagon. So my apothem is 1.7. That's easy to see. The perimeter would be 5 times 2.5. Since every one of those sides is 2.5, I would say 5 times 2.5 and get 12.5. Now, if I say for the area, all I got to do is 1/2 the apothem times the perimeter and type that in the calculator, and I would get 10.6. Easy, right? I know, it's so easy. Okie dokie. Here's another one. Oh my goodness gracious, how many sides is this? Okay, first off, I can see that there's an apothem of 18.1. The perimeter, there's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides. 8 times the 15 would be 120. So I would say the area is 1/2 the 18.1, the apothem, times the perimeter of 120, and I should get an answer of 1,086 inches squared. Simple, right? Yeah, see, not too hard. So, that gives me areas of regular polygons. How about composite figures? What is a composite figure? A composite figure is a figure that can be separated into regions that are basic figures. In other words, you got to do a little bit of thinking. I know that might be a little scary for some people, but you got to do a little bit of thinking, and you just got to like be able to apply. So let's look here. Let's see an example. Here you see a composite figure. I can break that figure up into a trapezoid, a semicircle, and a triangle. The semicircle, don't forget, is just half a circle. Okay, so if I find the areas of all three of those, since they're all like together, I can add those up, and I would get the, and so you can see here, here's me like saying, okay, there's my base, there's my heights, finding the area of the trapezoid. I'm going to find the area of the semicircle. Again, the semicircle is half of a normal circle. Notice how the radius is 1 because the diameter, that semicircle has a diameter of 2. And then for the triangle, half of the base times the height. And since once you get all three of those areas, all you got to do is add all three because they're all together. So that's pretty easy. Just got to make sure you see the shapes that you need to do to create the formula. So you see here, I found the three areas. Now I'm going to add them all up, and then I would say go ahead and tell me, that would be my final answer. That would be the area of the whole figure. I'm getting there. Don't worry. And there we go. So the area would be 35.16 feet squared, or 35.2 if you just round it to the nearest tenth. What about if it's something different like this? Oh no, I don't know what to do. Alright, first off, again, keep in mind I'd have to give you the height, or I'd be kind enough to give you the height. So you're looking at a rectangle and a triangle. The difference here though is that the triangle is taken out of the rectangle. So, and notice here that I'm saying this 6 is the base and 2.6 is the height. I would make sure to give you all the information you need. You just got to apply it correctly. Since the triangle is taken out from the rectangle, this time I got to subtract. I don't add. So I would subtract, and then when I do that, I would find out that the shaded area, the area of the composite figure, is 22.2 meters squared. Give or take a decimal or two because it depends on round-off error. Anyways, that's it for today. Just wanted to make sure y'all see how to do these. Again, I don't think anything that difficult, but I'm confident that y'all will be able to do it. So that's it for today. Thank you so much for your time. Y'all take care.